Hello. Today I'll be talking about our work on how we might get social robots out of our labs and into the real world. I lead a lab called the People and Robots Laboratory, and an important part of the research mission of our lab is the successful integration of robotic technologies into human environments. This goal requires that we design these technologies for long-term use in real-world environments. Enabling long-term in-the-wild interactions requires addressing a number of research challenges. For example, going beyond looking at specific design variables as we do in lab studies and integrating design guidelines into large systems. Understanding the extent to which our findings from lab studies apply to real-world situations. Better understanding the role that context plays in these interactions and adapting to context, and many more. To illustrate some of these challenges, I'd like to give an example where we explored long-term interactions with a reading companion robot. Our efforts started in 2016 by developing a reading companion robot for children where the interaction involved children reading out loud to a desktop robot and the robot providing social support, motivation, and so on. We designed the learning companion robot by integrating a number of known design guidelines about connection making, social norms, reading, and motivation. We conducted a 2-week study that compared the robot's use against a paper-based baseline. We found that children retained their interest in the robot and the reading activity and reported increased motivation and perceptions of the robot as a social agent. We also had a number of observations of how children actually used the robot in their environments. We were encouraged by the findings of the study and decided to conduct a 4-week-long study with a richer set of behaviors and interactions around reading science-related books with a social robot. Children read with the robot daily, which involved getting book recommendations from the robot, reading to the robot for a period of time, and getting comments from the robot while they read. The findings of the study was a bit different from what we had observed in our prior work, that children fell within 4 different groups. Those who modified their interactions with the robot, those who completely discontinued interacting with the robot, those whose interaction with the robot was interrupted for external reasons, and those who adopted the use of the robot as we had designed. And as we dove deeper into our data, we observed that our design lacked consideration of a number of important factors that affected children's interactions with the robot, such as how external events, children's interest in the activity, changes in their perceptions of the robot, and so on affected their interactions with the robot. So we need a better understanding of real-world human-robot interaction to design better systems. Having said that, designing and developing the reading companion robot was a significant undertaking, and we did our best. So if we want to build more sophisticated robots, we're also going to need better design tools. These point to the 2 types of work that my group is doing that I'd like to talk about for the rest of my talk on design principles and design tools. To start with design principles, I'd like to quickly go over 2 example projects. The first project studied initial interactions with the robot, focusing on the moment when a child opens the box of a robotic product and starts interacting with it. We envision robots as social agents, but robotic products still come in conventional product packaging. Should they be introduced to children as products that we have to unpack and charge, or as friends that they have to meet? To better understand children's expectations from meeting with a social robot for the first time, we conducted a field study of how children unboxed a robotic product. This was followed up by co-design sessions where children envisioned what the box should look like, how it should be related to the robot, and how they should be meeting and interacting with the robot. These design sessions generated ideas around different themes and metaphors that the experience of unboxing a robot would follow. We prototyped and evaluated a home for the robot that had its own social character and served as a butler for the robot. The box guided children in their initial interactions with the robot. This was a very fruitful project that allowed us to think about how a social robot should be introduced into a real-world environment. The second example I'd like to talk about is our exploration of whether the activity of taking care of a social robot could be a mechanism to foster child-robot connection. For this exploration, we first wanted to understand the caretaking tasks that children currently perform. explore robot caretaking tasks, and see how these tasks can be integrated into their day-to-day routines. We found, for example, that children engage in a number of caretaking activities, from taking care of pets to babysitting siblings. We explored how children might charge, clean, put away a robot in similar ways, and explored how these tasks can be integrated into existing routines. We explored 2 care routines, one focusing on connection making and another on utility. For example, the connection routine involved preparing the robot's bed, giving it a hug, and tucking it into bed. We found that children who followed this routine reported feeling closer to the robot and that they were becoming friends with the robot. Next, I'd like to give a few examples of the design tools that we're exploring that focus on enabling long-term in-the-wild interactions. The first project involves directly capturing real-world social interactions from designers into the behaviors of the robot. We built a programming environment called Synth that involved tracking the speech and nonverbal behaviors of the design teams and asking them to act out how they wanted the robot to interact with its users. Designers provided multiple demonstrations, and the system built a program that can realize all demonstrations, implemented on the robot, and simulated the behaviors on the robot for testing. The second example I'd like to give puts this acting out into the physical context of the interaction. We built a tangible programming environment where designers act out an interaction using a set of figurines to express how they want human-robot interactions to take place in human environments across different types of rooms, around different types of furniture, involving different types of verbal and nonverbal behaviors. The figurines are placed in an environment that designers describe, and that their behaviors are expressed by moving the figurines both on the environment and also actuating the figurines to express nonverbal behaviors. The last example I'd like to give is an approach to adapting the behaviors of a social robot to the preferences and expectations of different social environments. This approach involves starting with a baseline robot program and iteratively gathering user input to identify good and bad traces of interaction and searching for new programs that might prevent bad traces and promote good traces. We evaluate our approach by comparing the adaptive robot to a non-adaptive robot in a field study and found the adaptive robot to obtain significantly higher interaction scores. With that, I'll close by reiterating that we need to develop new design principles to support long-term in-the-wild interactions with robots and new design tools that can integrate these principles into social robots. I presented example projects from our recent work, but I believe that this is a rich space where more work is needed. If this line of work is relevant or interesting to you, please do get in touch, and thank you very much for listening.